This is systems of equations solving using the substitution method. Now, you can solve any systems of equations using the elimination method, substitution method. The elimination method is probably used the most, but sometimes it's set up just right for the substitution method, and I'm going to show you two of them. So in this case, we have y is equal to minus x squared minus 4x plus 12, and y is equal to minus 2x plus 4. So this is a parabola, this is a line. Okay, so if y is equal to this equation and y is equal to this equation, they must be equal to each other. You can set them equal to each other. Or you could look at it this way. If y is equal to this equation, I can substitute that equation for this y. Right? Minus 2x plus 4, that is your y. Equals what? Equals this, the minus x squared minus 4x plus 12. So now, I'm going to move everything to the other side of the equal sign. In other words, I've eliminated the y. I have nothing but x's. And when I have one unknown, I could solve that. And because here I have a minus x squared, I don't like dealing with that. I'm just going to multiply this whole thing by minus 1, so I get a positive x squared. And of course, the other signs will change. So this is negative, so I know my signs are different. My factors of 8 are 2 and 4. This is positive, so the big number needs to be positive. So therefore, x is equal to 2, and x is equal to minus 4. Why 2 answers? Because it's a parabola. All right. This is a parabola. This is a line. There's going to be 2 answers because they're going to cross, and the line is going to cross the parabola in 2 different places. So now that I've found my x, I'm going to take either equation, but it's easier to work with this equation, and one by one plug my x's in. So minus 2 times 2 is negative 4, and a negative 4 and a positive 4, of course, is 0. So in this case, when x is 2, y is 0, so the solution here is 2, 0. I do it again, and plug in my other x, which was minus 4. So minus 2 times minus 4 is a positive 8, and an 8 plus 4, y is equal to 12. So therefore, the solution here is minus 4, 12. So that's how the substitution method works best with this, where you have y equals something and y equals something. You set them equal to each other. The y has eliminated, and solve for your one unknown, your x. The other situation is equations like this. And this is 2 lines, x plus y equals 10, y equals 2x plus 1. Well, this is telling me what y is equal to. Y is equal to this equation. So I can take that equation and I could substitute it right into this y. So I bring this equation x plus y. And what is y? 2x plus 1 equals 10. And I have again eliminated the y. So all I have is x's. 2x and 1x is 3x. So this is 3x plus 1 equals 10. And now, with just one unknown, it's easy to solve. X is equal to 3. And of course, I take either equation, plug in the x that I've already solved for. So y is equal to 7. So the solution here is 3, 7. So as you could see, similar to the elimination method, when you substitute, you also eliminate one of the unknowns. Here we eliminated the y's because we set the equations equal to each other, because y is equal to that equation, y is equal to that equation, so therefore they must be equal to each other. And in this case, I was told what y is, and I plugged it right into this y in this equation, which eliminated the y. It left me with just x's, and I was able to solve that. So this is the systems of equations substitution method.